Hello learners, welcome to the NIOS studio. Today we are going to conclude the solids part 2, and in this part we are going to conclude the types of stress. What is a stress? A stress is an internal restoring force which acts per unit area of a deformed body. Restoring force, what actually the difference between a force and a restoring force? A restoring force which when removed regains the original shape and the size is known as restoring force. So, here we can say the restoring force acting per unit area. The dimensions of stress are very similar to that of a pressure because pressure is nothing but known to be the force acting per unit area. But in the terms of stress, the applied force is being replaced by the restoring force. Since the dimensional formula are in terms of Newton per meter square, therefore, it comes to be ml minus 1 t minus 2. Under the term of stress, the very first type is a normal stress. What actually is a normal stress? Here we need to emphasize that the term normal in terms of physics is nothing but perpendicular to the surface. As you can see, here it is a hollow cardboard, and if we try to imply a perpendicular force over to the surface of this cardboard, then this term came into existence as a normal stress. So, therefore, we can say that when a deforming force acts normally over an area of a body, that term stated to be a normal stress. Now, under the topic of normal stress, there are three more type of further stresses. They are the subtopics of normal. So, the very first type is a tensile stress. What is actually a tensile stress? If there is an increase in the length or extension of the body in the direction of force applied. As you can see that here we are having a wire as a demonstration. The length of the wire means it is having a dimension of length, but the breadth dimension is next to negligible. So, if I stretched it outside or try to imply an external force outside the wire, it will get stretched. And I can say the implied force is normal to the surface of this wire. Similarly, if in the same manner the external force is implied inward, it will get compressed. So, in the next slide we can say that if there is a decrease in length of the wire due to the force applied, here again we need to see that the force applied is normal to the surface. And the last one is the hydraulic stress. So, when a solid body undergoes a change in volume without any change in its geometrical shape on applying the force perpendicular to every point of the surface of the body. Through the statement, we can see that taking the example of a sponge, there is no change in the volume if we try to imply a normal force on every side or can say every surface of this sponge. But the geometrical shape do changes. For example, if we imply a normal force from the downside as well as from upward, it will get compressed and the geometrical shape changes from the term before when the force was not implied. Similarly, if on the side surfaces we are trying to imply an external force, then again the force is implied here a normal. Normal again implied to the perpendicular force on its surface. Here again geometrical shape changes. So, till here we had learned that stress are basically of three types for a solid. They are again the extension, the compressive and the hydraulic one. After that, apart from the normal stress, we are having the other type of stress which is a shearing stress. Shearing means when a deforming force acts tangentially to the surface of a body, produces a change in the shape of the body without any change in the volume. Now, again, taking an example of this hollow cardboard, which is having an actual shape of a cuboid, which consists of a certain length, breadth and height, and all the three dimensions are totally different. So, rather than implying a normal force, we try to imply a tangential force. A tangential force means we are trying to imply the force over to the surface. It will act tangentially. Therefore, when we imply the tangential force, the original configuration changes in terms of the shape, but the volume remains the same. As you can see that this part of this cardboard will get slightly aligned towards the other end. Rather, if we take again the volume, it will be same as that of its original shape and the size. So, this term comes out to be a shearing stress. That's it for the today's conclusion, where we had learned about stress, the two types of stress, that is the normal and the tangential. Under normal again, we have subtopics of stress due to the length, means the extension and compression, and due to the volume, that is the hydraulic. Thank you.